All right, let's dive in. Today we're looking at some really cool research that basically turns a huge idea in AI completely upside down. You know, in the world of AI, there's been this mantra for years: bigger is always better. The whole game has been about scaling up, building these massive models with hundreds of billions, sometimes even trillions of parameters. And the logic, or so it seemed, was simple. The bigger the model, the smarter it must be. But what if that's all wrong? What if just throwing more computing power at the problem, brute force, isn't the only way? What if a smarter, way more efficient design could let a tiny model run circles around the giants? That's the big, provocative question we're digging into today. Because as it turns out, these giant AI brains, they have an Achilles heel. Yup, a surprising weakness. For all that incredible power, they can get totally stumped by problems that need pure, focused reasoning. And hey, this isn't just a hunch. This quote from the research paper lays it out pretty clearly. Even the most powerful LLMs can really struggle with hard, logical problems. Think about it. They generate answers one word at a time. So if they make just one little mistake early on, the whole solution can just fall apart. So what are we talking about here? What kind of puzzles? Well, imagine the absolute toughest Sudoku puzzles you've ever seen, or these incredibly complex 30 by 30 mazes. And then there are these abstract geometric puzzles from the ARC-AGI benchmark, which is literally designed to test for general intelligence. On tasks like these, a lot of the big-name LLMs just completely faceplant. Okay, so to try and crack this nut, researchers first came up with this really interesting, but honestly super complicated model. It was definitely a step in the right direction, but it came with its own baggage. This thing was called the Hierarchical Reasoning Model, or HRM for short. The big idea here was to use two separate neural nets that kind of recursively talk to each other at different speeds, trying to reason their way through a problem. It was a pretty wild idea, and you know what? It actually worked. It beat the big LLMs on these tough puzzles. But man, was the design complicated. We're talking two networks instead of one. It was justified with these really complex arguments from biology that were hard to pin down. It even relied on this shaky mathematical justification that might not have even been the right tool for the job. And on top of all that, it was a pain to train. So yeah, it worked, but it was messy. Real messy. And that brings us to the hero of our story today, a brand new model that took the core concept of HRM, threw out all the complicated stuff, and simplified it down to something elegant and way more powerful. Let's meet the Tiny Recursive Model, or TRM. The folks behind TRM basically asked a brilliant question. What if we just strip away all the complexity? You know, get rid of the two networks, ditch the shaky math and the biological arguments. What if we just laser focus on the one thing that actually seemed to be the secret sauce? This idea of thinking about the problem over and over and over again. And this slide just lays it all out, side by side. Look at the difference. HRM, super complex. TRM, dead simple. HRM used two networks, TRM uses just one tiny little network. HRM leaned on those shaky theories, TRM just uses standard backpropagation, stuff we know works. And just check out the side difference. TRM is almost 4 times smaller. We're talking just 7 million parameters versus 27 million for HRM. It's a huge difference. So what exactly is this simple but powerful idea at the core of TRM? It's something called recursive reasoning. And honestly, the best analogy is to think of an artist. An artist doesn't just paint a masterpiece in one stroke, right? No, they start with a rough sketch, then they step back, look at it, erase a line here, re-sketch a detail there, and they repeat that process over and over, refining the drawing with every single pass. That's exactly what TRM does to find a solution. And here's a look at the model itself. I mean, look how simple it is. That's the whole point. You've got the question, a guess for the answer, and the scratch pad for its thinking. It runs all three through that one single network, and then, and this is the magic part, it loops. It feeds the output right back into the input, getting a little bit smarter, a little bit better every single time. Okay, let's break that down step by step. First, it starts with the inputs, the question, an initial guess at the answer, and that scratch pad for its reasoning. Step 2, it recursively updates that scratch pad, basically thinking through the problem multiple times. Step 3, it uses that new refined reasoning to improve its final answer. And finally, step 4, it just repeats that whole loop up to 16 times, getting better and better with each cycle. It's iterative thinking in action. All right, so we've got this tiny, simple model that thinks like an artist. It's a great story, but the million-dollar question is, does it actually work? Well, get ready, because the results are frankly staggering. So first, let's just anchor ourselves with the size of our contender here. Our little champion has just 7 million parameters. Keep that number in your head. Now, let's look at the giant in the other corner. A model like DeepSeek R1 has over 671 billion parameters. That is nearly 100,000 times bigger. This is the definition of a David versus Goliath story. And here we go, the results. On the super hard Sudoku and maze puzzles, that massive 671 billion parameter model, it scores 0, a big fat 0%, nothing. The older, more complex HNM, it does okay, pretty respectable. But then look at TRM. Our tiny 7 million parameter model gets up to 87% on Sudoku and 85% on the mazes. It's not just winning, folks. It is absolutely crushing the competition. And it's not a fluke. Let's look at the ARC-AGI test, that benchmark for general AI reasoning. It is the exact same story. Our tiny TRM outperforms its bigger predecessor, HRM, and it even scores higher than a cutting-edge model like Gemini 2.5 Pro. This is proof positive. Less really can be more. So, what does all this mean for the future of AI? Because this is way bigger than just solving Sudoku puzzles, right? What we're seeing here could be pointing to a fundamentally new way of thinking about how we build intelligent systems. So let's boil it all down. What are the big takeaways here? First, smart design can totally beat raw scale. Brute force isn't everything. Second, this recursive, iterative way of thinking, it's like a superpower for reasoning problems. Third, and this is a big one, being smaller can actually be an advantage. TRM avoids something called overfitting. That's when a model just memorizes its training data instead of learning to generalize. And that's a huge problem for giant models when there isn't a ton of data. And finally, all of this could kickstart a whole new wave of these super efficient, specialized AI models. And that leaves us with one last really fascinating question to chew on. For so long, the dream in AI has been this one giant all-knowing brain, right? An AI that can do everything. But maybe the future looks totally different. Maybe it's not one giant brain, but a whole team of tiny, brilliant specialists like TRM, each an expert in its own area, all working together. It really makes you wonder, doesn't it?